Okay, hello everyone. Welcome to our AI Meetup. So this is our last meetup this year, and we have two amazing speakers from two different companies. But before that, I want to also show, as like we're showing every time, our website and our OKRs. So what is the last news? So we have this our December meetup. We also tomorrow have AI Awards, which is most important event in all our meetups and all the Lithuania AI Association. So then we have also nominees for the Intellectual Art Contest. We also have winners right now. So yeah, so I want to invite you tomorrow. I don't know if we have place right now, Linus. We still have place? Couple of place, yeah. So if you want, let's go after this meetup, talk with Linus. Maybe you have like additional seat to AI Awards, which this year will be held in Mo Museum. So, and we have like a lot of different AI specialists and also amazing nominees nominated this year. So, okay, so I think we can start with our first presentation. Today we only have two presentations. Juozas is sick, so we hope to ask him to do like this presentation next year. But I want to present our first speaker, Alexander. Just one moment. Yeah. One moment. Stop sharing the screen. Okay. Yeah, it's two screens. How to switch? You know? Davidas, help me. Yeah, it is sport. Sorry about that.
Let's see if that helps. Not. It's a different. It's a different screen. Do you want what to appear? This preview, right?
Yep.
And it's not even opening here.
No.
Let's turn off the
Turn
similar.
on again.
And it's downloaded.
And it's here. Yeah.
So can I guess drag it?
I think minimize this one.
Mm-hmm.
Maybe it's in our desktop.
What if you just do like oh, you have a full screen here. This like close full screen on this. If you just click on anything here.
Open and then here.
Yeah, and now Control Command F.
Yes.
Okay, yeah, so Alexander, the stage is yours.
Okay, thank you. Okay, we're ready. My name is Alexander. I work in Planner 5D company, and I want to present on the theme of the how we use the similarity data for training different similarity model and solve our problem. One moment.
Yeah, just.
Okay. Where is? Okay. It doesn't work.
Let's try.
I think we'll lose the focus. Possibly
Yeah,
use
right now it's working.
Okay, thank you. For the start, a few words about the Planner 5D. Planner 5D is an application for interior house design. This product doesn't need some special skills. It's easy way for create your dream interior. Just create the room, add the wall, add the items, and create amazing renders. In my department, we investigate some new way to create models of interior. Because for create a really good interior, as we know, it's a room of middle size and contain a lot of items. It's between 30 or 40 items. And our catalog contain more than 6K items, and full catalog contain 2,000 items. It's a big number. It's very difficult for find something there. So we work on the task for find new way, simplest way to create the room. As soon as device this LiDAR is appeared, we started experiments with point clouds. The idea was give instruments for our user to create stand in Planner 5D by room scan. This task contained a two part. The first part create the room by walls, and another part find the items and add these items to the stand. Our advantages is access to realistic stands of interior from our gallery that have been accumulated over the years of working Planner, and our approach based of using some different generated data by the stand in training process. In case of point cloud, it is a synthetic points given from the 3D models, like from LiDAR. Our works was based on the article of structure-aware single-stage 3D object detection from point cloud. This work was about the outdoor scene recognition, but we try to adopt this article to interior design. A few words about the dataset. For experiments, we generated 37,000 bedroom layouts dataset. We extract from the items. I try to generate the point cloud. And we try to, in this task, we just try to extract and predict only 4 types of items. And the result of work you could see on the slide. On the right, you could see the point cloud. On the left, the scene in Planner 5D. And another example, this is source room, point cloud, and we just detect the item, and we try to understand which type of item we could see. And the item from our catalog was selected only by the category and size. In this case, we didn't predict the specific items. So in parallel, we investigated matching items by image. The idea was in render our models, the items in our catalog. It is 3D models, like a chair, table, or beds. And the idea was just render these items and give some synthetic data set and try to make the search by this image, by render image from the real image. And the first attempt was classification. And on the clearest data, when we have only one item on white background, we could receive accuracy around 30%. But the classification idea was we just each classes, it's each item ID. For example, in catalog we have 200 chairs. We had 200 chairs classes in this approach. So, but the accuracy was dropped when we increase the count of classes. So we try to find the way for solve this problem, and we use different approach. For example, we try to use variation of the encoder for produce embedding in variation texture. So the first image is input image, the middle image is representation is in this case, and reconstruction model. As we can see, the reconstruction image too similar like input image, but it doesn't help us to increase the accuracy. The next attempt was using fast Fourier transform for extract from the model only important features from the image. We just represent by the image generate the fast Fourier transform representation and make some compressed image and try to reconstruct again. As we can see, the image doesn't change critically, and we try also to use this compression representation for the search and try to train model by this. But the problem, this accuracy wasn't solved, and we stopped experiment this direction. And now we concentrate on the TensorFlow similarity library, and now we use it. It works better than previous approach, and we start collect the data set. We already have high quality render image from our database, from our catalog users gallery. It's around 1.5 million HD renders image, but we add some image for it, this mask of segmentation, this normals, depth normals, information about models and orientation. You could see the example, high quality render, masks and depths. For example, for single chair model, we have from 300 to 80,000 examples in the dataset. It's very unbalanced dataset, but for us it is not problem because we could modify this scene and just add not balanced items to the scene and render again and receive very balanced representation of our catalog in datasets. Next, on this slide, represent the main pipeline, how it works. The input images, it's images like a photo, these different items, and we use masker CNN for instant segmentation, for understand which items we could see on the scene. We use this model just out of the box. It's enough on this stage of development, and after it we try to use our similarity model to find the best items from our catalog, which we could see on these photos. About training similarity model and mask fusion, input image contain a lot of information, and we will understand which part of this image content item, and we need some way to say our model which part of image interesting us. So we use some approach for define this ROI for our model. We pass it in special channel, this mask for say our network. For us, interesting only this part of whole image. About training similarity model, we modify loss parameters was changed because default value wasn't good, but in the result after modification and change the parameters, we could receive on training data set the accuracy around 70% of images. It was very good for us, But when we can start to work this real data, we have a big problem about the data gap between realistic data and synthetic data. Synthetic data was extremely clear masks without any noises. Synthetic data already includes some cases with overlapping items. In real life, we haven't clear items on the floor. Usually it's about this different trash. We have a table with different items, and it is a big problem for us. And our accuracy was dropped to just 10%. So how we could try to solve this problem? We make some augmentation for images, and we try to modeling these cases and modify our data set for investigate the problem. In the result, we could receive the accuracy was up to the 30%. 30% it's not less for us because it's top 5 accuracy, and how we can see next. For example, matching items for one images. As usual, we could find correct item in top 5, but it's never placed in the first place. And we try to compare with other solution, and they also some similar results. For example, you had some very famous chair, for example, from the IKEA. We exactly know which its models, but only Google objectives find directly this item. As usual, another searching system could find these chairs, but it's placed 3rd place, 5th place, 10th place. Yes, it's already find it, and we received like these results. And the next stage. This summer was released new version of iOS SDK, this new functions of room scan. This function already implemented the first part of my presentation. When we try to detect the wall, we try to detect the item, they already doing. In the result of capture, we received the captured room information, this part of walls, the some bounding boxes of items. And for us, in the result, it was obvious for us, we need to connect our item matching, this room scan, and implemented it. I don't know, it will be works. Okay, try. I want to show the example how it works. It's example of session, how it works. We try to scan the, okay, it's not, it's show there, but okay, it's now. The main problem is to show the video of the presentation. No, it's full screen mode again. Okay, without it, I can show on the next slide. Just close. No, it doesn't work. Okay, no problem. In the next slide, I can have the image, this example of result of this room. Just change the slide. But I think it's okay. It works. Sorry, I want to show the video how it works from our application. It's example of scan. On the left, it's the photo of real room, and the right, the result, the project in Planning for ID without any manual modification of project. We receive this project is table, chairs, doors, windows, and correct size. It's very nice result for us because we didn't do anything in our editor. For best results, also we add some tools for colorize our default model. We try to extract the main colors from the image, just comments. We just use the masks, and from the list image we receive the main color, and we in our models we calculate the main materials just by array of the coverage of the items and try to change, and in the start it's received good results for us. Okay, in the end, I would like to say it is not an end for us because but now the quality of results it's not very fast. You could make 2 or 3 sessions of scan for received really good results. Very often we received the result without items or these incorrect items. So the main problem for us it's correct input data. The input data is very noisy without only part of items and find correct items. It's very difficult for us, but we work on it. That's all, I think. Also, this feature already implemented in our application. You could test it, for example. Question?
Okay, great. Thank you. Maybe someone has some questions, Alexander? Yeah, Jeff?
Thank you for the presentation, for the image. Thank you for the presentation, for the image similarity model. As I understand, you do the extraction of the object itself, then you extract the mask of that object, and then you extract features, and then you use it in some similarity search in your catalog. Have you considered using off-the-shelf models without training them? I don't know, you could even take model from DALL-E, and that would be a pretty good feature extractor already for image similarity. You wouldn't need to train from scratch.
No, we use only our. I not understand directly. As I understand, you ask about how to extract the features from the render.
No, I know how to extract the features, but you train from scratch your own similarity model. And
yes.
I argue, why do you do that? Because there are plenty of models that can do that already, that are already good feature extractors.
Yes, but it doesn't work on real data because it's for our task. In reality, we have some array of objects which we must find. And for us, the main problem, find the best representation, filtering data at best parameters of searching, to find exactly items by not full data. Oh, okay, thank you. It's example which I say. We didn't do it anything new. In real, it's just engineering task, and our task just find the best parameters and find solutions for gap problem between synthetic data and realistic data, because you can't find any open data set, and you can't use some open data set in the commercial development, not research, for implement this feature. And our task use synthetic data which we have. It's a lot of scans of real users, and preparing the scans for ask main question how to use a lot of synthetic data this real world.
Other questions? Oh, then probably thank you very much, Alexander. And our next speaker is Daniušis. So probably you can join. I quickly stop sharing the screen.
Давai padarom, kad būtų screen mirror, kad tiesiog lygiai tas pats, kas čia ir ten. Sure, aš galiu turėti.
Bet reikia šitą pinčiuoti. So, couple of minutes, we just make our setup better, and then Povilas can represent. Okay.
Šitą parsisiunti viską.
Yeah, so, yeah. Yes.
Share screen.
Okay, so please welcome Povilas Daniušis from Neuro.
Hello, everybody. I'm Povilas from Neurotechnology. Today I will present presentation about how to measure statistical dependencies by using maximum norm and characteristic functions. So the work was conducted by Neurotechnology and also Vytauto Didžiojo Universitetas and Vilnius Universitetas. So this presentation has three parts. First, we shortly review theory, which leads to our contribution, formulate this contribution, then discuss few experiments with it, and also provide few applications of generally dependent measures for various machine learning tasks. So what is statistical dependence measure? It is there is no very strict definition what it is, but some properties which would be good to satisfy. So let's X and I are two random vectors of arbitrary dimensional. For example, X is 1024 and I is 128 or something like this. So if we construct function D, which is 0 if and only if when X and I are independent random vectors. Also, if increasing values of D corresponds to the increasing statistical relatedness in some sense between X and I, and also would be good to have differentiability to include in neural network pipelines. And of course, good property is that this measure can be computed easily. So our main motivation is measure and optimize statistical dependencies more efficiently comparing to state-of-the-art or modern new methods in various tasks. And examples of dependence measure, well-known Pearson correlation, it is satisfies those properties probably in Gaussian case. Frobenius norm of cross covariance matrix, if we take covariance matrix between X and I, and we take all squares of its entries, it can detect linear dependence. And its generalization is H-sig, which is Hilbert-Schmidt norm. Also popular measure is mutual information. It is also a dependence measure. So shortly, what mutual information is such an expectation, but in practice it is hard to compute since we need to estimate densities. And for this sake, we use so-called Donsker-Vadrahan estimator, which is defined in the second row. So we take neural network F, and we maximize this quantity with respect to neural network parameters, and this thing converges to mutual information. So this approach is called MINE, or mutual information neural estimation. Here I include some code to try if you would like. So speaking about characteristic functions, we define joint characteristic function and marginal ones. So basically, if you see from definition, it's like Fourier transform of probability density. So now we define delta, which is joint characteristic function minus product marginal, and this quantity is 0 if and only if we have independence. So the idea is to measure statistical dependence by evaluating norms in LP space. So previously was proposed so-called distance correlation. If we take P equal to and use some weighting function, W, it is very convenient to express, because this ugly integral becomes just data distance correlation. And another interesting case, if we take P converge to infinity, in this case, a norm becomes maximization problem because just this thing converges to maximum. So we use this approach in our development. So we define dependence measure between x and I, maximum of this delta. And empirically, when we have data xj, ij, we compute this measure like this. And currently it is submitted to journal. If you would like to try, there is a code repository with this measure and various experiments. So some properties, our measure is between 0 and 1. It is equal to 0 if and only if there is statistical dependence. Also interesting property that under full rank linear transformation, if we multiply x and I by two full rank matrices of square matrices, we have the same measure. Also interpretation when x and I are zero mean Gaussian vectors is that it is very closely related to canonical component analysis. So now first application. This is supervised feature extraction. We compute features like f equal matrix W star times original sample. And find this matrix by maximizing this quantity. So we maximize projection, dependence of projection, we Wx, and dependent variable I. And use logistic regression on those features, comparing accuracies. So we compare 4 methods in our experiments, 3 dependence measure, our measure, HSIG, which is basically equivalent to aforementioned distance correlation, and recently proposed mutual information estimator, which is far more efficient than standard mutual information estimator. We use 21 data set. So basically we have 252 method comparisons. Interestingly, almost 77 cases, they are statistically equivalent. But in other cases, some of the measures provide better results. So in 20 cases, our measure was better than others. In 18 cases, mutual information, HSIG and HCA was better in smaller number of cases. So conclusion that this measure is similar or better in comparing to the modern dependence measures in feature extractions context. Another experiment, we try to look how neural network learns. So this task is melanoma classification, standard data set classification task. We use ResNet, which is fixed and trained on ImageNet. And on this ResNet, we stack 3 fully connected layers. And we measure dependence during training process. We measure dependence between input to this multi-layer perceptron and 3 layers of neural network. And also we measure dependence between output, and correctly there should be I, blue, DFEI, should be not X, but I. So we measure dependence between output and outputs of different layers. So here, for example, we have dependence between input and first layer, second layer, third layer, similarly with I. So what we see from this graph that during training, network first learns to compress input. So red line is going down. It means that dependence between input and outputs of different layers decreases. And similarly, neural network tries to fit data in the blue graph. We see how it goes. So dependence between outputs of different layers and output variable increases. So this task is very closely related to so-called information bottleneck approach. So intermediate conclusions that dependence measures are like more general characteristics compared to non-task invariant ones. So they look at some kind of dependence, not taking account whether there is classification or regression or other task. Also, dependence measure can be used as components of more abstract cost functions and in various algorithms. For example, we can convey information between layers of neural network and do other tricks. So let's review a few examples how those dependence measures are applied in several tasks. So first task is unbiased representation learning. Let's say we have training set in the upper row. So we have class 0, which is circles, and class 1, which is triangles. However, each sample also has some attribute, which is in this case is color. So we train classifier, and now we have test set. And in test set, we have incorrectly classified samples. Because representation is biased, it actually learned not the shape, but color in this case. So we wouldn't like that our decision would be based on this attribute, which is color. So trick is very simple of this article. Minimize task loss plus some constant neutral information. Z is model bottleneck layer, and C is vector of those attributes. So in this case, we need also not only like xi, but xic, which C are attributes of some data. But this approach was accepted to quite good confidence and showed good results. Another classical example which relies on dependence measures causality. Let us assume that X and I are one-dimensional data. I is additive noise model with noise independent on X. On other side, if we look to another model which X is function from I plus another noise, and noise is independent on I. So we need, in order to distinguish whether X was generated from I or I was generated from X, it is causal inference problem. We need to check which of those equations is incorrect. And in theory, it is a good thing that almost always one is correct and another is not. So basically, we fit models, we compute residuals. For example, we have this case. And the main thing that this noise should be independent on input. In first case on X, in other case on I. So let's say we have such situation. So in first graph, we have that the residuals are independent on the input. And in the other graph, we have opposite case, because noise is not equal. Noise depends on value of X. So in this case, noise is uniform in all cases, in all X. And in this case, here we have lower noise, and then also lower in the middle largest would depend on X. So it is based on statistical dependence measures. Another interesting and quite popular task is self-supervised learning, where we essentially make artificial labels, for example, from data to get useful representations. So this article uses H-seekers dependence measure. It takes input xi, computes some random transformation, like crop or something, like in case of images, and fits function f is parameters theta, maximizing or minimizing this loss. So also probably was accepted in the Neurotechnology in good confidence. So this demonstrates that dependence measures are used in various algorithms, and probably it is sometimes good to think about that they are, how to use them. So that's all. Questions, please.
Do you have any question for Povilas?
Thank you for the presentation. I think it's an excellent work, and I would love to see more of this kind of work in Lithuania. So that's lovely. It seems like it's something that could actually appear at Neurotechnology. So this is nice. I have a few questions. So you did an experiment with it, which is similar to information bottleneck paper, where you study the dependence between layers. And to be specific, why did you do it for 3 layers? Why didn't you just try studying, for example, some bigger models? Or was it just to show essentially that your method works?
Basically, I needed writing article. I needed second problem to solve. One was supervised feature extraction, another like to look how neural network learns. Of course, it is possible to take many layers and look into them. Also, would be interesting to train full network, including this ResNet. But the problem is that feature dimensions of some layers are quite large, and in large data, it is sometimes not easy to estimate statistical dependence with many measures. So our measure practically works like with thousands probably of dimensionality, or 10,000. One classification task was 10,000 probably. But I'm not sure whether in such large dimensions it converges to real thing which we want to estimate actually. So it's converges to something useful.
So a follow-up question to that: because I played around with mine before, and I remember they're quite sensitive to the hyperparameters that you're using when optimizing them. Have you done any comparison in terms of robustness of your measure as compared to other measures?
Not.
Because I think that would be quite interesting.
Yeah. But in our measure, good thing is if you look at number of parameters. So alpha and beta, 2 parameters. Alpha is dimension is equal to input dimension, and beta dimension is equal to output dimension. It's a very small number of parameters. If you look at mine, it is like neural network, which is clearly, even in linear, if it is just linear function, which is not enough for mutual information estimation, it has larger number of parameters.
And then a follow-up question: if your method is using less parameters, I wonder if you could study larger models, like language models. It would be interesting and insightful, I think, to apply this to this model, because no one has studied that. And that would be in itself contribution.
Yeah, it really would be good to make experiments to compare various in some like generated data scenario to compare different estimators, like mutual information, HSIC, and this one. And
Thank you.
Any more questions? If not, I think pause. Okay, I think we still have some time. So before we go into networking part and having pizzas and everything. So I want to show you also a couple of things, like free websites that could probably help you, like when you're doing research or like just reading, as myself. So yeah, just one moment. Yeah, so I will. Do you hear me like this? Okay, great. I don't know if you hear about this application. So yeah, I need to disconnect. Yeah, so basically what is happening, it's this application is created to like just, if you don't know like what paper is about or like what is term, is because if you're reading like some new subjects, an example, probably in Povilas, I don't really know like so much about causal, and so then you can like easy just like what is recurrent models, and the AI just showing you like the, what is recurrent models. And I'm mostly like reading my paper like this. So I have like a couple papers from CVPR this year. And these like quite hard to read if you don't know like all the subject behind this. Like an example, what is perspective and point or something like that, and you can like easy to find like the right definition for that. Then it's like quite easy to read all these papers, and it's pretty good. You can like do this follow-up questions, like similar to. It's not that good at ChatGPT, but it's like especially for papers. So
what kind of engine behind this?
So it's I don't really know. They don't release like what language model is behind it, but probably what they say, they just like, if you see like this meta model Galactica, which they release, and after 3 days they just shut down the model. So this is like quite similar, and they just train on like on most of the all archive papers, so that model can understand like what is like different definitions and stuff like that.
Basically, this is not the direct extraction of something, it's aggregated.
Yeah, exactly, yeah. Another, probably maybe, it's called Luna Labs. So this is mostly for like 3D things. So they have like also app that you can basically create. So on a new iPhone, you can, yeah, so you can create like, just download the app and you can create from like models. Okay, I don't have anything right now, but yeah. So basically what you do, like just go through like the specific object, and you can create like almost like 3D object in your like pocket, so you can reuse it. They're using Instant Nerve, which is from NVIDIA, and it's like pretty cool. I'll try my couple of models, and they look good. And probably the last one, I don't know if you hear about Hugging Face, probably yes, but they have like these called spaces, where you can check like the different models, what is creating like every week. And this is basically, I don't know, they have right now more than a couple of thousands that like generate every day from speech, text, ChatGPT, decoders, and other things that could be interesting. And you can reuse it, you can find the models. They also have diffusion models and different kind of measures. Yeah.
There are so many models here. Do you have a suggestion? How do you find good ones?
Yeah, mostly you just looking most likes. Yeah, so DALL-E Mini was like before DALL-E was released, then like Stable Diffusion and running. So these one are running on T4. So these people are paying like for compute that these models like would work faster. So yeah.
Let's
And
go on Stable Diffusion. Maybe some people don't know.
this one?
Yeah.
Okay. But I think prompt, what's the prompt? It's like the hardest thing.
Conference, hyper-realistic.
Let's try it. Okay, it's not working because it's not on 54.
It's a day in US, so.
Okay, I don't have any image. An example, Bill Gates could be like this. So you need to like pay for your compute if you like create the model in here and like upload it, and then you just pay for compute, which is like quite expensive if you like using P4 in the month of cost like a couple of €100. So yeah, so you can explore. There's a lot of different things. I also released a new Whisper model on Lithuanian. So it's also on T4 because Hugging Face subsidized it for a couple of weeks, but that's after that. Yeah, so.
Do you want to show us?
Yeah, of course. Where's my model? Sveiki atvykę, mano vardas Davidas. Okay, I'm not speaking that good, so.
You have some accent.
Yeah, probably. I'm not originally from Vilnius, so probably. Yeah, but I try to transcribe some YouTube, so it's working also quite, not like 100% well. It's like still VAR is like 20%, but yeah.
I have a question. Did you train on synthetic data?
I train on Common Voice data sets. So Common Voice is like the share. So people go into Common Voice website and share their voice, and also check if people are sharing the voice, they're like saying the right things, basically like that. So, and they're doing like this demo week, which they giving compute to train on different Whisper models. So I have on the small, and this was on the medium. I trained for like 20 hours of A100. It cost me around €50, something like that. Yeah, but it's also outperforms like the Whisper original one, the big model, and other models on the Common Voice benchmark. So
Thank you.
that's all. Yeah, so I don't know if we have more time. Yeah, we have more time. Okay, maybe someone has some questions around, yeah.
You could probably create more data for Whisper. Just extract sound from YouTube.
Yeah, I have all the Liepa data set for like
But also
1,000.
YouTube, you could just get the sound from YouTube.
Yeah, of course you can.
Like, is it possible to like generate the data for this, like to train it more and more? For example, to take like a
Yeah,
common sound
probably.
and, like, try to describe and then correct and put like that.
I don't know, like ChatGPT working on this reinforcement approach that they like retraining the model and checking what is. Maybe it could be also interesting to do this on speech, but yeah, it's probably needs more compute and more data. Yeah. But I think it's impossible to like with Lithuanian language achieve like very good result. We have like huge data set right now, the Liepa, but it's still hard to like, if someone knows how to prepare the data correctly, give me a call. Yeah, because I need that.
What big is the data set?
Liepa, it's like 1,000 hours. So this one I trained was 20 hours. So 1,000 hours probably improve a lot, but yeah, it's still hard because it's like Common Voice and these old Whispers only like checking 2 minutes chunks, and in Liepa it's like 20 and 30 minutes, like just one chunk, like a couple of chapters of book or something like that. So it's like quite hard. You need to do all these like different, like split your one huge audio file into like 2-minute pieces that I can give to the model.
But what is the challenge? I mean, I would imagine splitting is not difficult. Is it the alignment that is difficult?
Yeah,
Input
yeah.
and output? But then what is the objective that Whisper trains on? Because there is a loss based on dynamic time warping, but you then don't need the alignment between input and output.
I think you still need it because they like use this like, I don't remember like correctly what approach they are using, but I know like they just give a lot of hours, like 600,000, I think, and use like very similar approach. Like Vav2Vec is using like different transformer approach, but they don't even use like transformer for this.
Okay.
Yeah. So if you want, you can try it. I think for 1 week, I still have like T4. So
Alex Graves from DeepMind has this paper he written like a while ago where you don't, it's a loss function where you don't need alignment between input and output.
okay, I need to check that. Yeah. Okay, then. So I think we can start right now networking part. In a couple of minutes, we have pizzas, drinks, and we can talk more. So thank you very much, everyone who's participated today. And thank you, everyone who's watching us on YouTube. Bye, everyone.